Today we're doing some troubleshooting on this 1990 through 1996 Trip Monitor. It's also called a Digital Information Center, Telltale Panel, something like that. Customer complaint is that the photocell is not causing the brightness to change. This is a panel that has been restored by us already, and so I'm curious to find out what we see here. The first thing that we've done, we've set our meter to ohms for resistance. We're going to measure the resistance of the push buttons. What I'm using is just a standard header. I have removed the factory wiring harness connector. 1 is at the top of this module, 5 is at the bottom of this module. When no buttons are pressed, we see approximately 2.15, 2.16 K ohms. This is across pins 2 and 3 of the Trip Monitor. The way the buttons work is that they change the resistance that is presented to the body control module. When we press the buttons, we see 100, 45, range is 185, trip is 309, fuel is 500 ohms, trip is 926 ohms. So the push buttons are working as they should. Let's move on to the photocell. To measure the photocell, we're going to measure the resistance across pins 1 and 2. When we make it go dark, we see that it's approximately, well, it's still rising, 5, 6, 7 megohms. It's in the megohm range when it's dark. When we allow normal room brightness to fall on it, we're going to see somewhere between we see about 2.5 K. Anything less than about 80 K will cause this this to run at full brightness. Again, darkness causes the resistance to be in the megohms range. Bright causes the resistance to be somewhere between 2.5 K and 4 K. That's exactly what we should see. Next, we're feeding 12 volts to pins 4 and 5 of the Trip Monitor switch panel. That powers the bulbs internally. And what we can see when we block out the room light is that indeed both of those bulbs are working as they should. Finally, I'm going to take my 12 volt supply and I'm going to test each of the warning bulbs. They're all working as they should. So let's go ahead and reassemble the factory connector. I see no broken traces. This flat flex PC board. Because I have it here, I'm going to go ahead and just measure resistance. Pins 1 and 2 here. And indeed, we see the same thing. We see about 2K applied when the photocell is in room brightness. I wasn't able to film and measure the resistance of these connections at the same time, but off camera, we went ahead and measured the resistance of the photocell, the resistance of the buttons at the factory wiring harness connector, just to make sure we didn't have a break between here and there. And everything is working as it should. So this Trip Monitor panel is going to get a clean bill of health from us. We're going to go ahead and ship this back to the customer. Thank you so much for watching this troubleshooting video of this 1990 through 1996 Trip Monitor panel. My name is Bryan Thompson with Batee Corvette Repair. To find more how-to videos like this, as well as parts to fix your Trip Monitor panel, you can go to batee.com. That's BATEE.com. Thank you.